Hi, today we're talking about fractions again. We're going to focus on halves today, as well as thirds and fourths. So let's think about this in the real world. If I had some graham crackers and I offered to share with you, and I said, "Do you want half?" Would this be half? No, it wouldn't, because they're not equal parts. Right, you wouldn't want that. If I ask you if you wanted half, you would expect them to be equal parts, the same size. When we talk about halves, they have to be two equal parts. When we talk about thirds, there are three equal parts. And fourths is, you guessed it, four equal parts. Okay, so let's look at some shapes. So here we have a circle that we have separated into halves. We have partitioned them into halves. You got to remember that word, partitioned. That means we're separating. So we have partitioned this circle into halves. With halves, remember, you have two equal parts. One part, two parts. Now, I have shaded how many parts on this circle now? One part. So I have shaded one half. Good job. Now how many halves have I shaded in this circle? Yes, two. I have shaded two halves, which made the whole circle shaded. We can also divide things into thirds, which would be how many equal parts? Good job. Three equal parts. Look at the rectangle on your screen. Three equal parts to be thirds. Now, if we shade one part of the third, how many parts are not shaded? Right. 1, 2. So 1/3 is shaded, 2/3 are not shaded. Look at your screen now. How many thirds are shaded? 1/3, 2/3. How many thirds are not shaded? Good job, guys. 1/3. And we could also shade in all 3/3. 1/3, 2/3, 3/3. I have shaded in 3/3 or the whole rectangle. Now here we have a square that is partitioned into fourths. So how many equal parts are there in this square? Good job. 4 equal pieces. When I think about 4 equal pieces, a lot of times I think about a graham cracker square. And if I were to share this with 4 people equally, I would need to partition it into 4 equal parts. How many equal parts do we have now? Oops, here we go. 2 equal parts. But if I divide them again into equal parts, oh, I didn't quite make that one. If I divide those parts again, I can have 4 equal parts. Okay. Remember, when we're talking about fractions, they have to be equal parts. So here I have shaded in 1/4. How many fourths are not shaded? Count them. 1/4, 2/4, 3/4. 3/4 are not shaded. Good job. Now we have shaded 1/4, 2/4. 2/4 of this square is shaded. 2/4 are not shaded. How many are shaded now? Smarty, that's a good job. 3/4 are shaded. And if we shade in one more fourth, how many fourths do we have shaded? 1/4, 2/4, 3/4, 4/4 are shaded. Good job, guys. Now, back to thirds. This is a circle that we have partitioned into thirds. So how many equal parts do you see here? 1, 2, 3. Thirds means 3 equal parts. Good job, guys. Again, even though this is a circle, we could still shade in 1/3. We could shade in 2/3. Or, I moved too fast, we could shade in 3/3. Good job. Now, as long as we are making equal parts, as long as we are partitioning into equal parts, we could divide that circle into fourths. How many parts do we have when we're talking about fourths? You guys know it. 1, 2, 3, 4. 4/4. Great job, guys. There's 1/4 shaded, 2/4 shaded, 3/4 shaded. How many are shaded now? That's right, 4/4. Good job, friends. Now, here are some examples of how we could look and identify shaded areas on shapes. This circle is divided into how many parts? How many equal parts? That's right. This circle is partitioned into 1, 2 equal parts. How many parts are shaded? 1. So 1/2 of this circle is shaded. How many parts of this circle are shaded? 2. So we have 2/2 shaded here. All right. Good job, guys. Keep working on those fractions, and I'll talk to you later. Goodbye.